Hello and welcome to Space, and this month we're taking a close-up look at one of the most mysterious planets in the solar system, Mercury. This month, a new spacecraft is setting off on a quest to study the closest planet to the Sun, and we've met up with some of the scientists who are fascinated by this enigmatic world. These are the best images we have of Mercury. Taken by NASA's MESSENGER mission earlier this decade, they reveal a cratered planet with puzzling features on its surface. Now the joint European and Japanese BepiColombo mission is heading there to take a close-up look.
The really big thing of BepiColombo is that we finally get a complete picture of Mercury. So with the MESSENGER mission, we've seen the northern hemisphere in parts really well. We've seen the southern hemisphere extremely bad because we've been far away. And for a planetary scientist, that's really driving you crazy because you have seen that one part and you don't know if the rest is the same or if there's something completely different.
There is a lot to learn because Mercury just doesn't fit our ideas of how planets evolve.
At least for me, it is a mystery. How has this planet formed? How has it evolved over millions or billions of years?
ESA and JAXA, the Japanese space agency, have teamed up to solve the mysteries of Mercury. Each space agency has a separate probe on BepiColombo. They'll fly together to Mercury, a 7-year cruise, before breaking into orbit. It is a tricky journey.
One special thing about Mercury is that it is a very fast rotating planet around the Sun. And so on one hand we are braking against Sun's gravity, but on the other hand we have to speed up our spacecraft so that we fly together with Mercury. And when we are there, then we can put our two orbiters in the dedicated orbits to do their best for science.
Once in the heat of Mercury's orbit, the probes go their separate ways. ESA's will fly close to the planet, while JAXA's will observe from a distance. A total of 16 instruments are on board, more than any previous Mercury mission. Hauke Hussmann from the German Aerospace Center DLR will use a laser altimeter to scan the craters, valleys and plains below.
We're making a map, and we're making a 3D map, actually. We're scanning the whole surface of Mercury with these laser shots, and with information on the spacecraft orbit and information on the attitude of the spacecraft, we can then reconstruct the topography of the surface, so a real 3D surface model.
That 3D surface model will be used to study one of the most intriguing aspects of Mercury, the fact it appears to be shrinking. Its calculated Mercury now has a radius 7 kilometers less than when it was formed.
The planet is contracting or shrinking. And at the surface, we believe we see these features as a consequence of this shrinking. And that is one of the points we would like to understand. Is it something typical for planets, or is it something unique on Mercury?
Another key goal of BepiColombo is to understand what makes up the surface of Mercury. The scientists here at DLR in Berlin have purpose-built a special chamber which can heat samples to 450 degrees Celsius, the daytime temperature on Mercury.
We're going to a very hot surface. We want to have laboratory data where we can actually compare. When we get data back from our instrument, what do we actually see? Because we don't have a sample back. It's not like the moon where we actually have a sample back. The only thing we can do is actually we can look from afar. And we look at something that's very hot. So we need to actually look at materials at the same temperature as they got on Mercury, which, as you can imagine, is not an easy task to do.
Previous missions found water ice on the poles and observed far less iron and much more volatile materials like sulfur and potassium than anyone expected. So the readings taken in this lab will be compared with BepiColombo's spectrometer to work out what Mercury is really made of. Jörn Helbert shows us the instrument which will do the job.
And that actually is our development model. So it's basically identical to what we fly in space. It's the same size, it's the same material. The difference right now is we have a glass, so we can actually see what's happening inside. That actually is the part that will look at Mercury. And if you look inside, you actually see that it's very reflecting. And it's very reflecting because we basically don't want to get the heat of the planet in our instrument. And so we try to get rid of as much heat as possible. That's why we built this very reflective, what we call a baffle, which basically reflects sunlight, which reflects all the heat of Mercury. And only what the thing that really goes in the center reaches our instrument.
Excitement is building over what we can learn about Mercury and its origins in our solar system. In particular, scientists want to know how geologically active it is. NASA's MESSENGER mission spotted volcanoes and signs of gases bursting out of hollows on its surface. But is that what's really going on?
With BepiColombo, that is one of our goals when we map these hollow, which are already mapped by MESSENGER, and we see differences, then we would find a proof that even today there's something ongoing on Mercury. And that would be a fantastic result.
One of the things why I like working on Mercury is we need to understand Mercury in order to understand how planets form. If we have a model that forms all planets but not Mercury, that model is basically useless because you need to get that one as well.
The long journey to answer those questions is only just beginning. BepiColombo will use the gravity of Earth, Venus and Mercury itself to gradually swing into position and will only enter orbit in December 2025, when the real science measurements begin. And now to the part of the show in which we take your questions about the universe and put them to the experts using the hashtag #AskSpace. And I'm joined by Olivier Vittas, planetary scientist at ESA. Olivier, we had a question from Hernan Reyes, who would like to know why we're not urgently heading off to go and look for life on the moons of Jupiter and Saturn.
Well, in fact, we are. We are preparing a mission which is called JUICE, for Jupiter Icy Moon Explorer. And we are going to explore the 3 icy moons of Jupiter, which are Europa, Callisto, and Ganymede. We are not exactly looking for life. We do that step by step. But our main goal is to really detect and characterize, so to know more about the liquid water, which are underneath the crust of those icy moons.
Is there one of those moons that you think is a better candidate to look for life, a place where there might really be something?
So at the moment, we think that Europa is one of the best targets, because we know there is liquid water a few tens of kilometers below the surface. We know the moon is very active, a very young surface, so it's a very interesting target to explore. So that's currently the base place, but we are going also to explore Ganymede, which is the largest moon in the solar system. In addition, Ganymede has an internal magnetic field, which makes this moon quite interesting to explore. We need to know how much water, to know more about the conditions, and then we will send another mission to further explore those worlds.
Olivier, thanks very much for that. Remember, you can ask your questions about the universe using the #AskSpace hashtag, and we'll try to answer them. And you can follow other space news on Euronews.com.